Welcome to this learning journey. My name is Vijay. Today we are going to learn about how to verify an ASIC or an FPGA RTL code using Cocotb. So basically Cocotb is a Python-based verification framework which works via PLI with multiple simulators, both commercial simulators as well as open source simulators like Icarus Verilog and GHDL. And it can be used to simulate code written in Verilog, VHDL and System Verilog. In this learning journey, we are going to start with a very simple example of an OR gate, and then we are going to build on top of that example until we learn concepts like drivers, monitors, scoreboards, coverage, CRVs, and at the end of this we are going to take a look at the different BFMs that come by default with Cocotb. So when we speak of an OR gate, we are to input OR gate, we are basically speaking of a logic which is represented like this, and we say that this has an input A, an input B, and an output Y. And generally we represent this gate via a truth table where we have A, B and Y. So the two inputs A and B and the output Y, and we specify all combinations of A, B and the corresponding Y output. So this will be 0, 0. For an OR gate the output is 0, 0, 1, output is 1, 1, 0, output is 1, and 1, 1, output is 1. So if we are verifying this, if this is our device under test, what we have are two input ports and one output port in our device under test, and what we are going to do is we are going to apply this pattern to the input A and B and check whether the output Y matches this. So let us get to our example. So here we have our OR gate module which has the input A, B and output Y, and we are saying assign Y equals to A or B. So this is our DUT. Next we'll go to our tests. So this is the basic template for all our test cases. Line 1 we are importing the Cocotb framework. Line 2 we are importing a few triggers. So timer is basically a trigger which says that trigger which will fire after n time units, n simulation time units, and we also have edge triggered events. So a rising edge event will be generated when a signal transitions from 0 to 1. Similarly, we have a falling edge event where the signal transitions from 1 to 0, and finally an edge event where the signal either transitions from 0 to 1 or 1 to 0. This is the entry point to our test. So we have defined a function called OR test, and to this our RTL DUT is being passed, and this has been annotated with a decorator called Cocotb test. So this decorator basically pulls in all the test related feature to integrate with the DUT. So let us start. We have said our A takes a value of 0, 0, 1, 1. Our B takes a value of 0, 1, 0, 1, and our Y takes a value of 0, 1, 1, 1. Now we have four vectors for four input vectors, so we will apply them one after the other. Dut.a, so we are now referring to the a port and we are setting its value to ai. So first it will be a0, then a1, and so on. Next we will do the same thing for the b port. Now we will wait for some time to elapse so that the input signal propagates to output. So this is also to allow the simulator to actually do a tick and increase the delta delay. And now we are expecting that the y value is equal to yi. And if the assertion fails, we want to print out an error message, so let's do that. And our test case for this OR gate is ready. Now the next thing what we want to do is we want to update make target. So this is our make target. What we are doing is we are saying that our Python module is ORTest, the file that we have just written, and our top level Verilog is OR gate. Okay, now let us simulate this. So it is saying OR test, the test has passed. We are getting a pass indication. Now let us assume that our RTL was incorrectly coded. So we have our OR gate, and let us say instead of an OR operation, it was doing a XOR operation. So let us try our test again. We again ran make. And now we are getting an assertion saying yi. This assertion is being triggered. We are getting a message that at iteration number 3 there was an error. The actual value from the DUT was 0, whereas the expected value was 1. So if we remember an XOR gate, the truth table for XOR gate for the same set of inputs is for 0 0 it is 0, 0 1 it is 1, 1 0 it is 1, and 1 1 it is 0. So this was iteration 0, iteration 1, iteration 2, and iteration 3. So this is the iteration on which this error is being triggered. Now the next thing what we would want to do is we want to take a look at the waveform to see whether it matches with what we are seeing over here. Now when we are working with different simulators, each simulator has its own way for specifying how to dump waveform. So one of the most common way for specifying this is via some commands in the Verilog code. We won't modify our original RTL code. So whatever is there in the HDL folder is our synthesizable RTL code. We won't touch that. What we are going to do is we are going to create a wrapper file for our OR gate. So we have instantiated the OR gate from our HDL over here. This module has the same IOs as our OR gate, and all that we are doing is we are adding this initial begin end statement. Okay, and over here we are saying that the waveform should be dumped in waves.vcd, and we should have a dump force. Okay, now I also need to modify my make file so that I pick up the source as OR test and give the top level as OR test. Now when I run my make command, I see that the top level is OR test. I'm not given the make target, so let us do that. Make OR. The folder is wrappers, not wrapper. And again my test case has run. I'm again getting the same assertion error, and this time when I see, it has generated a vs.vcd file. So let us open up this file. So we have our top level OR test. Inside that we have OR gate, we have our A, B and Y, and when we pull this we see that we have when A is 0, B is 0, Y is 0, A is 0, B is 1, that is this point, Y is 1, and then the next transition we have A is 1, B is 0, Y is 1, and then finally we have A is 1, B is 1. Since we change the code to be an XOR gate, the Y is 0, and that is what is causing our error. Also, let us take a look at what is being printed over here as a part of our simulation. So we ran make OR. Internally we are running make sim module equals to OR test, top level is OR test. This is basically creating the simple directory, then it is running our simulator, which is Icarus Verilog. To that it is passing various commands, but the main thing is it is saying top level is OR test. The simulation binary should be created in this folder as this file, and then it is passing our Verilog files orgate.v and ortest.v. After that it is running the actual simulation, and to that it is giving the Icarus Cocotb PLI and the VVP binary that we had created. So once the simulation starts running, all these prints are coming from Cocotb, and we can see that over here it is printing out the version of Cocotb, the version of the simulator, and then when it is printing something called as seeding Python with some seed value. So this is something which comes into play when we start doing randomization. For the time being we can ignore this. Then it says that it found one test, and it is running that. And then finally, at the point where it errored out, it gave an assertion error saying error at iteration 3, and it is giving details of what the error was. And then you have your test result where it is saying test passed or test failed. So one test was run, the test pass count is 0 and fail count is 1. And then this is how much time it took to actually run the simulation. Okay, so let us fix the bug that we had introduced. Our bug was in orget.v, so we change this back to an OR operation and we run our test again. And this time we got that our test has passed. Also, we can go back to our simulation waveform, reload it, and now we see even in the final cycle it has gone to 1. The next step is an assignment. So we wrote a test bench for an OR gate. Now the assignment is to create a test bench for an XOR gate. So there is an XOR uh, there's a folder which has been set up for XOR verification. What you are expected to do is you are expected to uh, come to this classroom, come to this particular verification, uh, take this link invitation. So I will be posting the link invitation directly. You can use that. Click on that. It says accept the assignment. So click over here. This will take some time. So you can just refresh the page. Now it says that the repo has been created. If you go to this repo, it has a HDL folder which has duty.v which implements the XOR gate. Then it has test folder which has duty_test.py which gives you the basic template for writing out your test. It does not have a wrapper folder, so you will have to create the wrapper folder and put the wrapper code over there. There is a makefile. Currently the makefile does not have any specific targets, so you will have to modify this to add the wrapper verilog code and then change the top level to the wrapper when you run this, and then create a make target. Once you have written out the code and submitted it, what will happen is I will show for the tutorial that we are currently running. So on this tutorial, when we push any code back to GitHub, there is this GitHub Actions, and within seconds it will fire a verification cycle. So it will go ahead and install Cocotb. It will install Icarus Verilog. It will install Cocotb, and then it will run the test in the tests folder. And then the results of those tests will be the waveform from the test will be picked up, and an artifact will be created. So here we can, if I come back over here, I can see that there is an artifact called waveform which is created, and if I download this, This zip file has the wave.vct, which can be opened using GTK Wave, and this is the same OR test that we had. Okay, so the assignment for you is to repeat the same uh, coding exercise with the XOR gate design.